You are live. Yes, that was it.
I know. It's always so painless. We don't have any of the come on YouTube because you've already got it connected and streaming.
Yes, I'm trickstery that way. You sound so dubious.
No. Sorry, I was. My computer was misbehaving. I apologize.
Yours too.
Yeah.
It's a great night for tech issues.
I had to bail to my phone. That's why I'm in a different
your phone? Yeah.
Yeah, for some reason my computer would not hook up to it.
The chat. All right. So did anyone give Abigail the info?
No, we were too
Waiting on
busy.
me? Okay, all right.
Yeah.
So Abigail, people normally don't hear this part, but I'll that Abigail will interview you for the first 15, 20 minutes of the show, and then thank you for your time, and then you're free to just close the rendezvous window and enjoy the rest of your evening.
Okay, cool.
Sounds good?
Sounds
awesome.
Good.
All right. Great. Well, let's just get started then. You guys ready?
Ready.
Okay. All right. Here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, March the 9th, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the impact of the Russian-Ukrainian war on spaceflight. Mars Hope sees an aurora on Red Planet, and an Earth-like planet may be orbiting in a dead star's habitable zone, and more. Joining me this week, we've got, to my right, Dave Dickinson. Hey, Dave.
Hey, I bailed over to my phone, so that's why it's a different view. But still here in Norfolk. So
I actually find the phone is sometimes better. Like the quality of the camera and the microphone on the phone is sometimes actually a little better. It's a little more stable. I find Zoom meetings can often go well when people switch to their phone.
When we were traveling, we did the Weekly Space Hangout this way every week anyway. So
yeah, exactly. Yeah. And we've got Dr. Moya McTeer. Moya.
Hi, Fraser. How's it going?
Good. Welcome back.
Thank you.
All right. Before we get into this week's space news, I just want to give a huge thank you to our good friends at the Weekly Space Hangout crew. They're our friends, our fans, our executive producers. They call the shots. We do what they say. And if you want that kind of ultimate cosmic power over me and the rest of the team. Go to wshcrew.space and they will hook you up. And I'm telling you, cosmic power can be yours. Just go to the URL, join the crew. All right, let's get into this week's special guest. We've got Dr. Abigail Frost. Abigail, welcome to the Weekly Space Hangout.
Hi, thanks very much for having me. It's a pleasure to be here.
The question I always ask is, who are you and what do you do?
So, I'm a postdoctoral researcher in astrophysics working in Belgium, so at a university called KU Leuven. But as you can probably tell from my accent, originally born and raised in the UK. That's where I did my undergraduate studies and my PhD. And mostly I look at massive star formation and also the multiplicity of massive stars. So when they're in at least groups of 2 or more. And I mostly look at this with like infrared observing. Is usually what I do. So, yeah.
Now you came to our attention because, I don't know, I guess you like saved the Earth. I'm trying to think how to describe this. You prevented a black hole disaster, which is that, we had all been saying that the closest black hole was a mere 1,000 light years away. That's just right around the corner. But it turns out it's not a black hole at all. Talk about your research.
Yeah, so this result was kind of the result of a kind of super collaboration between a couple of groups. The one that I work in Belgium and a kind of international team based at the European Southern Observatory. And so like 2 years ago, a group of astronomers led by a guy called Dr. Thomas Rabinius, they looked at some spectra of the system, the emission lines, the light signals coming from the system. And by modeling those, they thought, okay, well, something's a bit weird here. And the thing that they thought was weird was that they could explain their observations by saying that the system wasn't just full of normal stars, but one of the stars was actually a stellar mass black hole. So it's about a black hole around 4 times the mass of our sun, is what they said. But, there was a lot of different opinions are flying around. And also from our group in Leuven, we thought, maybe there's another way we could explain this. And by looking at the same data that they had used and kind of taking a different approach in our analysis and modeling, we were able to find that actually we're not so sure you do need a black hole here. You could potentially explain the system if one of the stars is a bit irregular. And the thing that was irregular is that it was a strip star. So its outer layers had been stolen by something. And we think that something was the other star in the system, which is what we call a BE star. And this is like a star that is rotating so fast that like the material at the equator is like being compromised. It's spreading out to this like disk structure. And essentially the only way we could definitively prove between the 2 scenarios was getting new data that look at the position of the stars, see where they were, and because it was all about the configuration. If the system had a black hole in it, then one of the bright stars had to be really far away. But if it was in a binary, then those stars were orbiting each other very closely on the period that the other people thought the black hole was orbiting one of the stars.
So with the original configuration, the thought was that you had like a 4 times the mass of the sun black hole, and it had like an accretion disk around it, and it was feeding from a companion, or was it just like no accretion disk and it was just like the radial velocity of the companion is what was getting measured?
Yeah, so it's actually, it's a quiescent black hole, so it's not doing anything exciting like, accreting material, because otherwise we might be able to see the shocks from that, and that would, help us to see it more clearly. But yeah, the reason that it was kind of so difficult to conclusively determine that it was there is because it's quiescent. It's not doing anything. It's just, as you say, in orbit around this other star and looking at the radial velocity is how we can try and detect it.
So this signal that they were seeing from this star, they just thought was one star. And then it was in, in this binary configuration with this black hole. And what you worked out is that it is actually 2 stars, none of which are a black hole. What they thought was 1 star is actually 2 stars. And they're producing all of this signal that was causing this confusion. Do I have that right?
So actually, they thought that it was a triple system. So there were 3 stars in the system, 2 of them the bright stars, and 1 was a black hole. And we determined that you didn't need the black hole to explain it. You could just have the 2 bright stars in a different orbit than they thought. So what
kinds of forces could cause a star to behave the way you're describing it? I'm seeing the picture on the screen, and it looks pretty messed up.
Yeah. So we think that these two stars have gone through this interaction that has made both of them now look a bit strange. So the way that this could start out is that the stars can both be very normal. You have two stars that are formed out of the same area, and they're kind of similar-ish masses, but importantly, one is a bit more massive than the other. And for a lot of the time of their lives, they'll, behave quite normally. They'll just orbit around each other, doing their star thing, nothing too complicated. But the minute that one of the stars begins to evolve into a giant phase, which is something that happens to all stars, it will happen to our sun eventually, it'll become a red giant. But basically, the largest star in the system will do that first. And if the stars are close enough together in their orbit, when this star swells and become a giant, it can become so big that it's close enough to the other star that that star can steal material from it. And then this creates this interaction, which, sucks the material of one star and can, change the other star gains that mass. It can change its rotation, its momentum. It can do a lot of different things to both the stars. And so that's what we think has happened.
How does this end?
That's a good question. So there's a number of things that can happen. So at the moment, we've got this BE star, which is that fastly rotating star with that disk that you can see in the picture, and we have a B star. But eventually, the other star was going to swell as well. It will also go through this kind of giant phase. Before that happens, well, actually, let me rephrase that. So we have this other star that has been stripped, and that's an important thing. And so essentially, because it's been stripped, its kind of evolutionary path is in a bit kind of changed now, and potentially it could go supernova quite quickly compared to if it hadn't have been stripped and it hadn't had this interaction. And so eventually what we might end up with is, you could have a supernova event, or eventually you could end up with a kind of an X-ray BE star binary, and you have a very active supernova remnant spewing all these X-rays into space because of this change in their mostly in their internal chemistries and the sizes that has happened through this interaction.
Right. So I guess if you do get a supernova, then you end up with either a neutron star, which is remaining, but I guess it's probably not massive enough to turn into a black hole.
No, we don't think so.
And it's definitely not massive enough to just vaporize itself completely. So you end up with some kind of remnant. And then you're going to have, and we see those around the universe, right? We see these neutron star in a binary configuration with another star.
Yeah, and a lot of the gravitational waves we've been detecting in the past 5 years, which have been also quite spoken about, are from these neutron star binaries, especially neutron star binaries. So yeah, that's also something that could potentially happen depending on how quickly the BE star evolves. These two stars are still in a small binary system, so potentially they could eventually lead to one of those kind of events as well. We don't know exactly though, and that's why we want to keep studying this star and understand a bit more about it and their specific characteristics, so we can try and work out what eventually they will do.
Yeah, I was wondering, because you see the star in this configuration, and because it is already starting to blow it up as a giant star, and it's on its way to death. And yet we also do see these configurations of neutron stars and other stars out there in the universe. Do you think this is maybe the path, as long as they're, I guess, close enough? Is this the path they all take? Or do you think this is a fairly rare configuration?
So, we can expect these kinds of interactions to happen quite often. We know that most of these kinds of stars, massive stars or B-type stars and O-type stars, most of them are meant to exist in at least a binary system, or potentially even a higher order system like a triple or a quadruple or something. And furthermore, we expect most of the stars that are in a binary system or a multiple system to interact. And so we expect that this stripping to be fairly common for these binary systems. It's one option that could happen when these stars interact. They could even merge. One of them could be stripped, like we think has happened here. They could also, kind of almost join together and share a common envelope as well. So there's a number of different things that could happen. So these kind of interactions should be very common. I think the main problem in detecting them is that the time this kind of interaction is so much shorter than the whole lifetime of the star, or both the stars in the system. It's just tricky to catch it just after it's happened, and also to have good enough data so that you can tell that one of the stars has been stripped and the other one is a BE star, for example. So
So what's next for your research?
So the plan is we'd like to keep monitoring the system. Essentially, now we have shown there's not a black hole in the system, and we kind of have a pretty good handle on what we think the two kinds of stars in the system are. But there's a lot more we can learn from them. In particular, we want to continue monitoring them. We want to get a much better idea of the exact orientation and the orientation of their orbit, because that could be interesting, particularly if it's aligned with the disk that we're seeing around this B star. And also by monitoring the stars throughout this orbit, we can get a much better idea of their exact masses and like the dynamics that are involved. If we put those into our binary evolution models, then we can get a much better handle on how this process can happen for lots of stars, not just this system that we happen to have caught in this rare stage. So yeah, and hopefully that can help us understand a bit more about these common interactions, which can really affect a lot of the stars in our universe, especially the most powerful ones.
Oh, very interesting. It's absolutely fascinating work. And I guess congratulations for, again, saving us all from a nearby rogue black hole. Instead, some kind of horrible rogue binary system with a supergiant star. Far safer.
Hopefully it won't bother us anytime soon.
Yeah, so. No, I'm sure we'll be fine. 1,000 light years, that's really far away. It'd be fine. Yeah. So if people want to follow your work and keep track of what you're doing, what's the best place to go?
So I recently got Twitter a couple of years ago, and that's probably where I post most about my work and talk about other stuff I do, like, talks I'm giving, or, outreach and other things to do with like diversity and sustainability in astronomy. So you can find me at astro.frost on Twitter.
Perfect. Well, thank you so much. Congratulations on your undiscovery, and let us know what happens next.
Great. Thank you very much.
All right. Take care.
Cheers.
All right, Dave.
Yes.
Let's talk about the repercussions of the Russian-Ukrainian war on literally everything.
Tonight, as a matter of fact, the war drags into its second week, and I noticed you guys covered it some last week, so I think I can do. I've been kind of keeping a rolling list because there's so many things that it's impacting out there across the board, and I've written about this for Sky and Telescope some. And I mean, of course, the ISS is the obvious thing, but right now everything seems to be more political posturing than any actual action with the ISS. I mean, we're seeing missions still. Next week we've got a mission coming back, and we've got a crew mission going up. And as far as I know, that's all still on. I mean, there's of course the head of Roscosmos has been having his Twitter meltdown, and we've all been following that and scratching our heads.
So can you go into this, because it's
what's really kind of getting really bizarre. I thought it was really wild, and I had to show my wife when he changed his Twitter profile to the Topol. I was like, that's a nuclear ICBM missile. It's like, could you even imagine if the head of NASA did that, for example, on his Twitter banner?
I mean, like the spat he's getting into with Scott Kelly
with the astronauts. That was what was funny, is that Scott Kelly told him, it's like, you could go work at McDonald's, and he's like, oh yeah. There is, and he did this in Russian because American astronauts are trained in speaking Russian. They have to be, because they go on the Soyuz. If the pilot becomes incapacitated, they need to know how to flip the switches and fly the Soyuz. So, it is kind of funny to see all this. It's very bizarre as far as but again, it all seems to be posturing right now, because I haven't seen any of that as far as with the ISS translate into action.
And did you see his video that he posted?
I saw that briefly, yes.
So he posted a video that with sort of like surging Russian music, which showed the Russian astronauts detaching themselves to the International Space Station and floating off. Like they spent money to simulate what it would look like if the Russian segments detached from the International Space Station and departed.
Yeah, well, they have the propulsion sections too, and the Progress vehicles are what they use. We think, again, we're all trying to interpret like what he's talking about when he talks about the ISS crashing into the U.S. I think he's alluding to the fact that they have the Progress modules which do the propulsion. But the latest Cygnus that went up there is one of the first one. It has that propulsive capability too. I don't think it would be too hard. NASA is looking into ways to move forward if we had to without the Russians. Right now, they're exploring that option. But I mean, it's impacting. OneWeb is a very good example. They got caught in the middle of it. OneWeb is a company like Starlink, like SpaceX's Starlink, that's launching these mega constellations of communication satellites. And just to show how international things are now, OneWeb is based in Florida. They use a Ukrainian carrier aircraft to bring their satellites to the Baikonur Cosmodrome in Kazakhstan to launch on an Arianespace, which is the ESA's Soyuz rocket built by Russia in Kazakhstan. So it's like, and they're not going to be doing those launches anymore.
Those are canceled.
But they're going to move to I think Kourou, and again the Russians are pulling out of doing Soyuz launches in Kourou and French Guiana, which they've done, which is an ESA site, which they've done since 2011. This may impact India's crewed space program, which they wanted to do some launches, but they were going to train with Roscosmos. That's up in the air now.
Oh, I hadn't heard about that one. Okay.
That the Korean space program, that they've been doing some launches, but their boosters for South Korea are made in Russia, so that's on hold now. ExoMars, I believe you guys caught that because the ESA, the joint ESA Rosalind Franklin Mars rover that was supposed to launch at the end of this year, it was joint Roscosmos ESA. That's going to be delayed now indefinitely. And you can think about there's a cost to all this.
Launcher and landing system were going to be Russian built. Yeah.
Think back to Galileo when that got delayed for the when we lost Challenger. That got delayed several years. There was a cost to that because they think by delaying Galileo, that was one of the reasons the antenna was stuck. That being in storage for that time, things corrode, fluids and whatever have different effects on things. They think that's why Galileo didn't function properly. This kind of delay could come at a cost too for Rosalind Franklin if it's under construction and they have to mothball it for a time. Rosalind Franklin's already been delayed several Mars windows for one thing or another. It was supposed to go, I believe, in 2018, way back in the day. So now we're looking at 2024 or beyond for that.
You've got the Antares.
Yes, Antares. Those are that was the motors for those were built in a factory in Ukraine. That's Northrop Grumman, but they launched the Cygnus. That factory sustained damage, so we don't know right now how bad that damage was. It's just showing how much everything in space flight is internationally connected now. There's nobody really operates in a vacuum anymore nationally. So the Germans, their E-Rosetta instrument, I believe Matt Williams wrote about this on Universe Today. It's where I caught it. On the Russian Spectre R radio observatory, they shut that off. So that was a joint German Roscosmos mission, astrophysics mission.
And they also canceled all their upcoming. They had a bunch more collaborations coming with Russia, and they canceled all of those. So those are all done. So literally every single piece of connective tissue between Russia and the rest of the world, except for maybe China, in human and robotic space flight.
This might be the time that's good that China, because of ITAR, just operates on their own frequency. That they have their own space station and they have their own missions, and they're not really as connected to the international space community as anybody else. I think there's another interesting story with all the data we're seeing from companies like Maxar and Black Sky. I've talked to Black Sky actually about all the I was in the Air Force, and we're getting a quality of open source data that we didn't have for classified data, like that you would see in briefings
about this.
In the 90s.
Yeah. So like these pictures of, say, the convoy and like there has, like, I've only sort of scratched the surface with this. I've sort of nibbled around in these open source intelligence communities. There's apparently hundreds of thousands of people who are in giant Telegram communities scouring pictures taken by Maxar and is it Black Star? Is that right?
Black Sky. Maxar is the big one, Black Sky, and there's about a half a dozen other smaller. Black Sky has its own satellites. They were launching with Rocket Lab on Electron rockets. And Maxar is a big one, but this is all stuff out there that is just for clientele that want to download these things offline. And a lot of the first images we're seeing of intelligence, like of what kind of movements and what kind of activity is going on, this is all going around the internet. But you notice it all says Maxar Black Sky in the corner. I mean, there are, I was reading yesterday, there are volunteers in Ukraine that are flying drones that are just like flying around and doing battlefield intel. These are just people that have their own drones that are flying them off buildings and stuff.
Yeah,
and it's
and
interesting.
Feeding this information back to hundreds of thousands of volunteers who are processing this information and getting it back to the Ukrainian forces.
And we're seeing so much of this intel now. I mean, this is almost like the first. If Vietnam was the first TV war and the Gulf War was the first CNN war, this is almost like the first Twitter, TikTok war. I mean, we had this ability around in Syria, but what I think is kind of bizarre is we're seeing a lot of this stuff out of context. You know, we're seeing a helicopter get shot down here, then we're seeing satellite photos from black sky, then we're seeing these other images of like rubble it's hard in real time to put all that. We're seeing everybody's trying to do what intelligence communities have always tried to do for years is put all this stuff into context and verify and see like where this is actually. And then we've got to debunk a lot of things too that come out that are obviously fake. So very bizarre to watch this on
and things like that. Yeah. I'm I just hope it stops. Like, just make it stop.
I know, like this is going to have a huge repercussion in the space community alone for years. Like it's interesting to see if the ISS weathers this or not. I really don't know what's going to happen. Like I said, all the posturing hasn't really translated into any action that I've seen. But you know, it's if it does, it just shows how redundant the ISS, our internet, that because in 2014 we almost went through the same thing as well.
Moya, you just.
I feel like I don't have anything to add here. I am learning a lot.
I've held up the International Space Station as this beacon, this example of two former enemies being able to come together and work together on a challenging problem that's too big for one country, and it's this place where these two former enemies can work together. And I had felt like that was like the backbone of future collaboration between these two countries, these two communities, and it fell apart in a week.
I forgot.
It all just snapped.
I watched last week's show. I forgot the reference to the movie 2010. I'm like, oh yeah, they did have the same situation in 2010 when they had the Odyssey mission at Jupiter. It was a joint Russian-American mission, and they were about to go at nuclear. I totally forgot that movie reference.
Yeah, I went back and sort of looked that up again, and the Roy Scheider says, like, just because our countries are being idiots back home doesn't mean we have to be idiots here, and sort of nicely disarmed it.
Oh, you might have caught too that we lost a minor bit of space history. The AN-227 Antov aircraft that used to fly the Buran, the Russian shuttle that was at Kiev airport, I believe it was destroyed. There was evidence. We thought it might have been, but it definitely was destroyed. Yeah. So that's a piece of space history that's no more now.
Yeah. So I wouldn't be surprised in next week we'll be continuing this conversation and have a whole bunch of new awful.
I think it's going to be put to the fore because we've got, like I said, we've got missions going up and coming down, crewed missions from the ISS. So I think it's going to be in the news again.
There is one last awkward situation. You've got a NASA astronaut who's going to be coming back on a Soyuz.
Mark Vly, I believe his name.
Landing in Kazakhstan with his two Russian compatriots.
Yeah. This will be an issue again next week, I'm pretty sure.
Yeah. SpaceX has said that they can fill the gap in boosting the space station if the Russians don't launch any more Soyuz up there. So
Yeah.
So they feel, but from what I understand, the configuration on the Dragon is sort of, they fire a little bit to the side. They don't do any damage to stuff around them, and so they're not configured nicely. The thrusters on the Dragon,
I think
which is
Cygnus would be a
different.
better bet. Yeah, because
Cygnus is better, and the Soyuz or the Progress is better, but
yes,
the Dragon in its current configuration isn't the right tool for the job.
And somewhere in the next year, Boeing is supposed to send Starliner too. That's been pushed back a bit, but Starliner should be another option to get back and forth pretty soon.
SpaceX has been sending truckloads of Starlinks
over to Ukraine, and they've been trying. And Russia's been trying to jam them too. So there's this odd cyber war going on as well.
And apparently it is making a huge difference. So, I mean, to be able to have a portable high-speed hotspot that you can have at any point in the country.
Elon Musk got into the Twitter war with Roscosmos too, because I believe he tweeted something to the effect of who will save the ISS if Roscosmos doesn't, and he tweeted the SpaceX logo at him.
Right.
So
well, he's got no love for the head of Roscosmos. He's been beefing with him, chirping with him for a while. So yeah. All right. Well, thanks, Dave. All right, Moya.
Ready for a rapid change of topic?
Yep.
Let's talk about some potential planets around a white dwarf. A team from University of College London published in MNRAS, actually back in February, but it's coming out in their April issue, that they found a regular pattern of debris orbiting a white dwarf called WD 1054-226, in case you want to look it up. Despite what the headline says, they are very careful to only use the word planet once in this paper. I searched through, and that's only to say that a planet here is one potential plausible explanation for what's going on. So what did they find? What data were they working with? They had 18 nights of observations with the UltraCam instrument on ESO's New Technology Telescope in Chile. They also were using light curves from NASA's TESS. So overall, they had observations spanning 2 years, from 2019 to 2021, of this system. And in the light curves, if you go to the next image, you can see all of the light curves that they took, all 18 nights. In the light curves, they found 65 clouds of debris that block the star's light by a few percent every 25 hours about. In analyzing that light curve, they ran a bunch of different tests. They found that the light curve isn't color dependent. So if you look in different wavelengths, the depth or the shape of the light curve doesn't change, which implies that whatever's blocking the light is a solid, opaque object. Like a planet.
Yeah.
They also saw that the dips occur regularly enough, this longer pattern of 65 dips. And they think that something is holding them in a regular, stable formation. So the idea is that there might be a planet there with moons and a bunch of other debris. Also, based on spectra, they had some spectral analysis of the system. It appears to have metal species in the orbit in these clouds that refract the star's light, which is one of the telltale signs of a rocky planetary disk around a white dwarf.
So are they seeing both a disk and a planet?
So they only say planet once. They see a disk. They see a light curve where the star is almost always being occulted by something, and it regularly has this repeated, complicated pattern of dips. And when you look at the different harmonic frequencies in that pattern, you can see that there are a lot of small pieces that are held in the same position by something that appears to be a larger piece.
Like some blob of a planet and then a bunch of other debris.
Mm-hmm. Mm-hmm.
Right. or like an asteroid belt
Or,
and a
yeah.
planet. Yeah.
Yeah, this is one potential explanation.
Right.
But if it is a planet, it would be pretty cool. It's actually, it would be a great temperature, but it would be interesting. It would orbit.
Be cool, but also warm.
Also warm, yes.
Yeah.
Language.
But it's in the habitable zone. Like that's the key.
That's the key. So a white dwarf's habitable zone is much smaller than even an M dwarf's. So this planet, if it is indeed a planet, would orbit at about 0.02 AU, well within the orbit of Mercury in our own solar system. And it would be in the habitable zone. They calculated an equilibrium temperature of 323 Kelvin, which is firmly in the acceptable range of 175 to 270 Kelvin, which is what we say it should have if it's a habitable planet. But they do think that the planet likely formed or arrived in this system. There are different dynamical mechanisms for that to happen after the star finished its red giant phase, because this white dwarf would have formed from a star probably like the sun that puffed up into a red giant, engulfed, if there were planets before, a lot of the planets in its system, and then would shrink back to a white dwarf. And so it's interesting that this is there, because we aren't totally sure how a planet would survive that close to a white dwarf.
But planets have been seen around white dwarfs before, and also debris clouds around white dwarfs, which it feels to me quite peculiar that it can capture a planet later on after it's gone through the white dwarf, but they're sure that the mass loss doesn't allow the planets that are outside of it to follow it inward, as it, or like its atmosphere somehow slows the planet down and then puts the brakes on it, but then the atmosphere blows away or something.
Right, there are those possible mechanisms. We haven't found a planet in the habitable zone of a white dwarf before. So this would be the first.
Right.
And the other planets, the first planet that was found orbiting a white dwarf was a hot Jupiter and not a rocky planet, as this would probably be based on the spectra of the system. But they didn't, at least in the parts that I read carefully, they did not talk about the different ways that a planet could migrate in and out of the system around the red giant phase. So, my chair shrunk again. But they did have this conclusion that they thought it probably formed after the red giant phase. And they analyzed how the system would evolve, and it seems like it would be stable in this habitable zone region for at least another 1 billion years. That's
so it's got 1 billion years of being in the habitable zone until the star cools down, where the habitable zone is inside or out
the star.
Yeah, within its orbit. Okay. So world build this for me for a second. What would it be like standing on this planet in this system?
It would be pretty dark. It would, imagine having a year that short. I think that's one of the things that I would find the most difference in, because they can see the stars around them in the 360 view many more times than we can, so they can learn faster about the night sky. I don't know.
Maybe tidally locked, probably?
Probably, maybe. They're really close, but
yeah,
also
that close.
They're not, the white dwarfs aren't that massive.
White dwarfs stay white dwarfs for quite some time, don't they? Like there hasn't been any white dwarfs that have burned out in the universe yet.
No.
Yeah.
That's all pretty amazing.
Years.
Yeah.
Before they become before they cool down to the background temperature of the universe, and none have done that. So, and yet it would be dark because it's more of a point source. I don't know,
it just doesn't give off anywhere near as much light as even an M dwarf does. So even if they are much closer and they can have a kind of okay equilibrium temperature, it's still going to be dim.
Huh. Fascinating. I can't wait to find more of these, because that means there's hope for us.
Exactly. Because this is like looking at our future of
our
solar system, and we maybe the sun will get to our place in the solar system when it becomes a red giant. Maybe not, but probably. It'd be nice if we could like migrate out and then back in after it became a white dwarf.
It's this like weird existential crisis that I have where I think like, oh, we've got whatever 5 billion years before the sun bloats up as a red giant and destroys all the inner planets and maybe the earth.
Mhm.
And then someone comes along and goes, no, we've only got 500 million years, because that's when the sun, the heating from the sun boils away the oceans. And like, oh, and I thought I had 5 billion years and now I only have 500 million years.
Maybe subsurface life might have another billion, maybe.
Sure, yeah, subsurface life will have more time. Right to the, it'll hang on right to the end. But it's funny because obviously, we're all going to be long
Right,
time
for sure.
before that. And yet, the big rip makes me sad if that's a possibility. I'll take the heat death of the universe over the big rip because that gives me another Google years.
Yeah, absolutely.
Yeah.
I will leave out the 500 million years bit when I tell young students about the evolution of the sun, because I usually just leave it at, oh, the sun's going to live for another 5 billion years.
Yeah,
fine.
yeah. You don't tell them the part where we're all going to boil in our oceans. No,
Right.
that's probably best.
Yeah.
All right, awesome. All right, Dave, your other story.
Yes, Mars Hope. I've been following this came out of the 53rd LPSC meeting that's going on right now. And this is some of the first science we're seeing out of the United Arab Emirates Mars Hope mission that launched in the 2020-2021 window, along with, there was 3 missions. So China sent Tianwen-1, Perseverance with NASA, and UAE sent their very first planetary mission, which was launched on a Japanese, again, this shows how internationally everything's connected. It launched on a Japanese H-2A rocket from Tanegashima, and it was built at the LASP in Boulder, Colorado. So this is an interesting mission. This is somewhat like MAVEN. It goes on a wide-ranging mission orbit around Mars to steady they want to stay in orbit around Mars 1 Martian year, about 2 Earth years, to steady the transition of the seasons in the atmosphere, in the surface. And they've got a suite of instruments on there, infrared, ultraviolet, visual. But they had an interesting finding on this one that caught my eye about seeing aurora on Mars, on the nighttime side of Mars. Now, this has been done before, but not to the scale that this spacecraft has done something to actually characterize different types of aurora. And they actually were on hand to witness a few solar events when they passed by. MAVEN has seen aurora, which is NASA's mission that's similar. That's just an orbiter that's observing Mars. But it sees aurora about 1% of the time. This mission, Mars Hope, sees aurora about 67% of the time, which is more than half the time when it's looking at the planet, mostly in ultraviolet. But there's been a visual component to this too. So
but Mars doesn't have a global
magnetic
magnetosphere.
Field. Yep.
So how does it have auroras?
It does have a very lumpy magnetic field that's local, and that's where this term discrete aurora, I had to kind of clarify from some of the researchers. I'm like, what's discrete about the aurora when you say discrete aurora? This meaning that it's localized in these. We have kind of a magnetic field map of Mars that's just in this, like the moon doesn't have a magnetic field, but there's lumpy areas around the moon magnetically that what they call mascons and things that have some magnetic properties to them. And that's where they're seeing these aurora correspond with these regions where there is not a continuous planetary magnetic field, but just a local, like bits and pieces of some areas are more, have some magnetic properties to them. I thought that was an interesting finding that came out of the LPSC early on. It's ongoing this week, but Ben MAVEN, there should be an extended mission. They actually released an interesting, I wrote about this a bit earlier, about an atlas of Mars where they took all their photos. Yeah, there's the actual from the infrared, the ultraviolet instrument, on MAVEN, or not MAVEN, but Mars Hope when they're looking at the nighttime side of Mars. So it's interesting that they're starting to classify types of aurora and see them linked to these solar events there. I've never seen them on Mars at this scale. What I would like to know is, could you see are these a type of aurora that you could see from the surface, or is this something that's only visible at that ultraviolet?
From what I understand, you can't.
I don't think.
Remember,
I wouldn't think they would be.
Yeah, I remember someone. When they turned up with Maven. I remember they're saying this isn't something that you could see with your eyes, but
because Maven was the first one a few years ago. We all wrote Aurora seen on Mars for the first time. So
that's right.
It's like,
yeah.
So I have to qualify this one with this isn't new to Mars, but we've never seen it at this scale. That Mars Hope is kind of giving us a much better view of this really poorly understood phenomena on Mars. I mean, we've seen Aurora on Jupiter and Saturn and even Venus and stuff too. But
yeah, it's really interesting. Did you see the atlas that they released? You mentioned it. Have you've taken a look at it?
Yeah, I wrote about it for Universe Today a few months ago, and I cruised through it. It's kind of interesting, and it shows some of that. Like I said, they're going for some of those seasonal changes, and they're getting some beautiful pictures of Mars from that orbiter. So
yeah, it's amazing to think that you've got Europe, you've got
Mars Express,
US, you've got
Mars Reconnaissance Orbiter.
Yeah, Mars.
Yeah.
You've got China, and you've got the UAE.
Mars Odyssey has been there for over 2 decades now, and it's still operating.
Yeah.
Mars Odyssey has been really kind of, people forget about it, but it's still operating there. It's a NASA orbiter, so there's quite a flotilla, and like I said,
4 different countries, and the Russians were planning to send one. Who knows if
it's too bad because the Russians have never been. I don't count Mars 3 as a success. I know some people do, but Russians have never really been successful at landing on Mars. So,
and the Japanese have their mission.
The Indians. There was an Indian mission.
The Indian mission, MOM.
I think,
and then the Japanese have their Phobos mission coming up.
Oh, they want. I think, I don't know if that's on though. Was that launching with Russia? It might have been.
Oh, I don't think so.
I haven't heard anything about it.
One?
No, I think that's a ways out though. It's a few years out.
I'm sure
it's unfortunate.
Japanese rocket.
The only one in the next coming window, you can only launch to Mars every 2 years, and the only coming was Rosalind Franklin ExoMars, and now that's so. For the first time, we're probably going to have a Mars window with nothing going. Usually, a few missions go every.
That's a total waste.
Window
for the first time since when?
Probably, I'd have to think back because we had 3 last time. We had European ESA Schiaparelli went in 2018, I believe it was, and that was Mars Trace Gas Orbiter.
Yeah.
What went into it's going to probably be at least since 2014-16.
I think went the previous
Mars
time.
Insight,
and then Curiosity.
Then you get back to Curiosity, I think 2010,
and then you had like the Polar Lander
that failed. But there was Phoenix. Phoenix was a copy of Mars Polar Lander. The NASA, the only lander they've ever had fail was Mars Polar Lander.
And Mars Express. So I would say for the last 20 years, they've used every single Mars
nearly
window.
every single Mars window. So
Beagle 2, Schiaparelli.
Yep, that was
European
UK
space agencies. Yeah.
Eagle
it's very
failed.
Impressive hearing you list all of these with the years and in order.
Well, we've been writing about these for this long, so yeah. I've been writing about these at least since Curiosity, and Fraser's been on this for even longer than that. So,
yeah. So this does feel like it's going to be the first time. Not even Elon Musk is going to be sending his first colonists in Starship.
Well, remember back when they were supposed to do a Mars flyby, a crewed flyby in 2018. That was back in 2014 and stuff. Somebody needs to keep track of all these. Like we're going to have a Mars colony mission, and remember Mars 1 that everybody was signing up to go to Mars. It's like that quietly folded and just went away too. So
I mean, I'm trying to think what's coming up. Like the sample return mission 2030.
That's a ways though. Yeah, that's
maybe.
I think 2028 or 2030. I think sample return.
Yeah,
they're doing the hardware for it now.
Yeah, and I know the Chinese have another mission in the works. Anyway, but like to have an unsent Mars window.
Yep, this may be the first like for at least a decade. So it's gonna. Yeah,
maybe Mars needs the break.
Mars needs a break? No way.
Just kidding.
No way. Mars has got too many secrets. No break.
I want Perseverance to keep functioning, so when they land the sample return next to it, we get the view of Perseverance gets the, because they're gonna have to land by within a kilometer or two of it
Yep.
to get the return. So we're gonna, for the first time, see that sky crane kind of landing that from the ground. That will be kind of cool.
Have you seen how they're planning to launch the rocket,
Yes.
the return rocket? They're going to throw it in the air.
It's almost like a Jack in the Box kind of setup.
Yeah, so they've got a spring that's going to hold down the return rocket. It's going to throw it up into the air, and then it's going to ignite its booster and fly off to orbit.
Yeah, I did see that video. I think is it Lockheed Martin's building that, I believe.
Yeah,
I saw their
so
brief video of it. Yeah.
Yeah. I've seen some animations of the thing being springed up in the air.
Yeah,
It's really cool. It's just you've got like some wires, I guess, to try and simulate Mars gravity. But yeah, you've got this giant rocket just being hurled up into the air, and then it gets caught, and then it comes back down.
We should see all that on the ground too. Like I said, Perseverance, if it's still functioning, there should be some video of that launch. That'll be kind of interesting to see.
Yeah, and they're going to have like a little chase robot that's going to be zipping across the landscape, picking up all of Perseverance's poops.
As far as I know, Ingenuity is still flying. I haven't heard. You don't hear much about it, but we haven't written it off. So
yeah, no, it's still fine. So yeah. All right, well, we've reached the end of our hour, so it's time to shamelessly self-promote what we're working on. So Moya, what are you working on, and where can people find out more?
You can find everything I'm doing on my website, moyamctier.com, or you can find me on Twitter at GoAstroMo. We'll link you to the website. Please check out my podcast called Exolore, EXOLORE. I have an episode coming out tomorrow talking about cosplay as world building, and I just put out an episode analyzing the Matrix as a whole. I think there might be a lot of people who have strong feelings about that fourth movie, and you can listen to what I think about it.
Hot take, I liked it.
That's valid. There were parts of it that were great.
Yeah. I thought it was fine.
Mm-hmm.
And it was meta. I enjoyed it. I actually enjoyed that movie. I thought I loved them just ranting about the system in movie form. I thought it was fun.
Yeah, I felt like I was in on the joke.
Yeah, exactly. Yeah. But then I'm very small invested in the actual sort of movie series. And so I thought they were all fine.
Nice.
Dave.
Frequent contributor, Universe Today, Sky and Telescope, Vionis Telescopes, author of Deep Sky Field Guide. See if I can get it. Yeah, I got
there you go. Keep going. Keep going.
Yeah. Deep Sky Field Guide and Universe Today. First book, second book. This is the first one, Universe Today, Ultimate Guide to Observing the Cosmos. Right now,
are you watching Dave do this? He's a pro at this. Take notes.
I literally am.
I have copies of my book in my backpack. I have copies of my book in my car. If you want to see a copy of my book, it's usually within arm's length.
Number one rule: book within arm's length at all times. That's like just rule number one. And so you're like, no matter what you're doing, wherever you are, you're just like, oh, and I've got this book.
Next season of Weekly Space Hangout, you're gonna get sick of seeing the cover of my book.
No, absolutely. It's the next doctorate book. That's the that's the progress of things. And if people want to keep track of where you are, like, what's the best place to go, Dave?
At Astro Guys with the Z, I'm most active on Twitter, usually just talking about what's going on in the sky worldwide. So
perfect.
And whatever I'm writing about. I'm thinking what we were talking about, like with Maxar and Black Sky, and percolating together a big article on like the open source space intelligence gathering. I don't think there's much being written on that. So I'm kind of...
I've had a really hard time finding this cross-section. I know exactly what you're talking about. It's a thing I would have assigned. So
I think there's a big story there, though, that's not really being talked about, because it's the first time we're seeing this kind of
like
massive open source intelligence,
where you go on like a Cosmo Quest, where you go onto this site and you just find Russian tanks. Like find
people people are trying to do like live action maps. Like I've seen that. Like there's live maps where they're trying to take all these little TikTok videos and pin them to where they're located. Like of all the different things go. There's some. I think there's some working in that direction to try to like aggregate all this intel together.
Yeah, and then provide that information. Like at the very least, there's going to be a reckoning when this is all over, and the more data and information that can be provided to, you know, when everybody goes to chat about it in The Hague, it'll be great to have this information. All right, I'm University Today at all the things. I've been doing a lot of really fun interviews with people who've been winning NIAC awards. This week, I got to talk to Nobel laureate Dr. John Mather, who was just such a treat to talk to. And we talked about his plans for a star shade for the extremely large telescope. So a star shade for a ground-based telescope, which is awesome. So definitely come and check out my YouTube channel. I got lots of really fun interviews. They're all mind-bending, and I think you'll really enjoy them. All right. Well, thank you, everyone, for joining us this week. Thanks to my co-hosts for hanging out and chatting. Thanks to our special guest. Thanks to everyone watching us, both on YouTube and on Twitch. Thanks to all the moderators, keeping everything civil, especially for such a divisive episode. And thanks to Pamela for operating the whole thing behind the scenes. Thanks to Nancy Graziano, as always, for herding all the cats. And we will see all of you next week. Thanks, everyone.